Yes. Share screen, whiteboard. Okay. Let me know if you see my whiteboard, please.
Here we can.
Okay. Sounds good. Where is my question? Yes. Okay. Last week we talked about the center of gravity point of the geometrical shapes. Today I will start with these examples. Oh, black. Okay. If I have a shape like this is y-axis, this is x, and here's just a second. I'm sorry. Stop the share. I need to close my Teams. I'm sorry. Okay. Share screen again. Yes. Okay. The shape is like this. It's gonna start from here and then goes up, and it comes here, then goes down and goes right, and then down. Okay, this is our shape. Okay, the geometrical shape, you know. Let me give you the dimensions here. Actually, this part here is 10, and then this distance is 20 centimeter, and this part is 20 again. And here in the vertical direction, here we have, and we have this part. You can see here there is a level differences between this point and this point. Here you can see the differences, and here is 15 centimeter, 5 centimeter, 15, and 20 centimeter. Here is the question: is calculate the centroid location of the given shape. Okay. Okay, we have our geometrical shape. It's like a complex shape. Here I gave you the axis system, x and y system. But if we don't give any axis system as an origin point, please select the most left and bottom point. As you can see, the origin is at the most left and the most bottom point. At that time, all these area will be in the positive side, positive region. That's why I use this method. You don't have to do this. It's a trick I use generally. Okay, if you like, you can put x and y. For example, let's presume we don't have this x and y axis. We can put x and y axis here. No worries. We can do this calculation at each point. But if we use this point, left-hand side shapes will be in negative region, for example, in negative side, negative x side. So I generally prefer to work in positive region for both axes. That's why I use this method. I put the axis system to the most left and to the most bottom point. So here you can see the our origin point. Let's get started to divide our section to the basic shapes that we know the area or the center of gravity points. Okay, let me divide this section. Okay, you can divide by yourself, that's okay, but I'm gonna draw what I did in my calculation. For example, I did this. I divided a triangle here. This is 1, and then here we have I made a mistake to draw. Let me clear this part. Just a second. I'm sorry. This point and this point are at the same level. It's gonna be like this. Okay. Can you please make this part correct? Okay. And then here I divide this part and this part. Here is 2, and here we have actually it looks like rectangle if you check the dimensions. In vertical direction 20, in lateral horizontal direction we have 20. This is a square. I'm sorry for my sketching, so no worries, we know the dimensions. We can solve it. This is 3, and this part is 4. We have 4 different pieces. We have 2 triangles and 1 square, 1 rectangle. So what we are gonna do? We are gonna draw our table. Okay, remember number AI XI YI, and then we are gonna up. We are gonna AI XI do this one, and I'm gonna do this AI YI. Okay, this is our table, and we have 4 members. Okay, we have 4 members, and we are gonna get the total numbers here at the end. 1, 2, 3, 4. This part is the total. We will do it at the end. Okay, we have this first piece. It's triangle, so its area is easy. Calculate the area of this triangle. So 15 times 20 over 2, right? So it's you can do it
150.
Yes, 150. And let's do xi and yi for this member. Let me change the color, orange. So xi, remember, we have a triangle. We are gonna use the 1/3 rule to find its center. Actually, its center is gonna be around here, right? So this part is 1. This portion is 2. actually this part proportional with 1, this part proportional with 2, totally 3. So what we have here, 20 over 3. Let me calculate the exact number. 20 over 3. Yes, 6.67. Okay, here is 6.67. Okay, what is the total xi? If you take a look here, check it out. Here is 10 and plus 6.67. Totally it's 16.67. Okay, 16.67. Is this clear? How we get this xi here? Any question for this?
Yeah.
Okay. Okay, we did xi. Let's do the yi. It's again, we are in this triangle. We are going to use 1/3 rule. The total is 15. So divide this 15 to 1 and 2 here. This part. Let me show. This part is 5. This part is 10, right? So let's calculate the total y. Totally here 20, 40, 45. Right? Here is 45. Okay, we did the first one. Let's do the second. Second is here. Second is here. Again, we have a triangle. If we have a triangle, remember we are gonna use always 1/3 rule. It's center point here, and this distance. The total is 10. Let me calculate that number. Let me calculate that number over 3. Yes. Here is, and this part, and this part is yes, totally it's 10. Okay, let's calculate the area first. Area is 10 times 15 over 2. I think it's easy for you. Let me check the number. Yes, 75. Xi is here. This distance 6.67. 6.67. Okay, let's do yi. Total height is here 15. So we are going to use 1/3 rule again. Here is 5, here is 10. The total distance to the x-axis is 20 plus 5, 25. Okay, we have just done the number 2. Okay, we are in 3 now. Let's do it. Let's calculate the area. Area is 20 by 20, 20 times 20. So 400 is the area. Its center is here at the midpoint. As you know, here, this total distance is 20. Let me change the color, by the way. Here is 10. Okay, and this part is 10. There is one more 10 here. Totally, xi is 20. And let's have a look to yi. Total height here is 20 again. This is 10 and 10. And here we have 20. Totally, it's 30. And we have the last piece here, the fourth one. Again, we have a rectangle. One dimension is 50, other one is 20, 50 by 20. So calculate the area, 50 times 20, it's 1000. That's okay. The center point is a midpoint in each direction. Here totally 20, this one is 25. And the vertical direction total is 20, half of it is 10. Yes. Now we have all areas xi and yi. Now, if you complete this part, you're going to use your calculators and multiply each number and write here. Okay, so let me fill in the blanks here. Let's write in red. Okay, I'm gonna write from my solutions here. And and 8,000, 12,000, and okay, we have completed all the table. Now, what we are gonna do, we are gonna calculate the summation of these numbers. Which numbers we need? We need this part, this one, and this one. So sum of the area, which is the total area actually, sum all these numbers. And what is it? Let me see. Yes. And here, sum all these numbers. It gives us and for this one, it's okay. Now we complete all the boxes in the table. So let's do the xg. What is xg? Total xi, sorry, ai times xi over total ai. And same for the yg, total ai times yi over total ai. So we're gonna do this calculations, which is this here. And then okay, what are the results here? Here, this one, and okay, you can see the center of gravity point of this section, but these given coordinates are according to our axis system adopted at the beginning of this question. Okay, according to this system. If you change your axis system, you're going to get different numbers here. It depends on axis system adopted. So I guess you get the point here regarding this, the center of gravity calculation. Is there any question so far? Nope. Okay. I'm gonna solve you one more problem. Where is it? By the way, let me add one more thing to this question. Okay, the second question for this one, for this shape is, if I rotate this shape around the x-axis, for example, 90 degrees, 90 degrees, what is the volume of the new shape? Okay, this is the new question for this example. Remember, we were using the Popes-Goulding method. I'm gonna write here actually. We don't need. The volume is the firstly we are gonna rotate this section around the x-axis. Angle times area times distance. That gives us the volume. Angle 90 degrees. But while we are writing angle here, what were we doing? Remember, we are not using degree here. We are using radians. The angle should be in radians. So we are going to convert it to radians. It's a kind of unit conversion. You can do it. It's like P over 2, right? This is 90 times area. Area is here. Total area times distance. Distance to that x-axis is, actually this distance is yg. So this one, and put it here. This gives us the volume. Let me calculate it. I don't have that number. P over 2, P times 0.5 times okay, let me write here. Okay, this is the volume when we rotate this shape around x-axis 90 degrees. Okay, any question regarding this volume calculation?
Hocam pi bölü 2 90 derece olduğu için mi yazdık?
Yes. Onu sadece radyana çevirdik arkadaşlar. Normalde pi'li yazılıyoruz ya radyanda. 90 derecenin karşılığı. Okay. Let's do another example. Let me see my notes here, what I have. This one. Here I have a 1/4 of a circle from here. Yes, our area is here. Here there is a opening, and here is y, x. 30 centimeter, and then 20 centimeter. Here we have a radius. This is a circle piece, and here we have 4 centimeters, and here 16 centimeter. Okay. Here the question is again, calculate the center of gravity point of this given shape. The first one is, okay, centroid location or coordinates. Okay, and what is the volume? If the shape is rotated around y axis. Okay. Here we are gonna do the centroid calculation, then a volume calculation. To do this, let's draw our. By the way, let's divide this shape to basic shapes. Let me change color, pink one. Here we can divide again this part. We have 1. This is a triangle. Totally we have here a rectangle. The total is a rectangle, it's 2, and 1 piece here which is missing part, 3. We are going to remove this 1/4 circle from this total rectangle. So we have 3 basic shapes. Let's draw our table again. This is the number AI, XI, YI, AI, XI, AI, YI. Okay, we have 1, 2, 3. Total part. We need to calculate this box, and this box, remember. So here we go. We have a triangle here, as you can see. Just a second, I will do it. Triangle, the area is, as you can see, this part 30, 24, 30 times 24 over 2. Okay, so it's actually, what is this? Turning in this matter. Let me calculate it. 2 times 24 over 2. Yes. This is the area, and let's do the dimension of its centroid. Here is the centroid. Remember, it's gonna be close to the highest point of triangle. 1/3 rule works again here. Total distance is 24. So this part is 8, this part is 16. So xi is 8. It's same for the vertical direction, totally 30. So divided 3, this part is 10, 10, 20. So totally from here to here, 30. Okay. Yes. Let's do the second member, which is a rectangle here. Its center is here. Let me calculate its area again. 40 times 20. Yes, you're right. Here is 800. Xi is totally 40, which is 20, and yi is totally, it's 20, so this part is 10. So we have this part now. We're gonna remove this area from the total area. So if we are gonna remove an area, before to start the calculations, we put a minus here. Okay, we are gonna remove that area from the total area. So what's the radius? Radius is 20, diameter is 40. So if you calculate that area, you're gonna see, let me calculate, by the way, the P. Okay, and then yes, it's like 314. Okay, 14 points. This is 16. So what was the rule for the circles? Remember, if we have a circle, let me change color. Its center of gravity point is here, and we used dirt for r over 3p. Okay, we're gonna use this method. So it's like, let me calculate, 4 times r. What is r? Here, 20 over 3 times p. Yes, here is in both direction, it's same, 8.48. xi is 8.48, yi is 8.48. Okay, now we have all unknowns from the geometrical shape. Now we can calculate the numbers. I'm gonna do this calculation because the results I have are in different units, I guess. It's not in centimeter. I don't want to convert them back. So I'm gonna do all these calculations now with you. I have calculator times, yes, here, and yes, yes, times. So we will get negative numbers here, point, and it's same again, right? Okay, here we have all the numbers. Let's do the summation. We are gonna sum all the areas here. Let's do it. Let's do it here. Plus minus here is let me check the again numbers. Okay. Okay. Here 16 point and then okay. Now let's calculate the xg and yg. Xg is here and this is yg. Let me calculate these numbers. And here okay, here you can see xg and yg coordinates according to given a coordinate system, axis system. This is the A. Let's do the question B. What is the question B here? Okay, rotate this area around y-axis. The y-axis is this one, around y-axis. 360 degrees. Okay, question B is volume. Volume. Remember, angle times area times distance to axis. Okay. This is the rule. You don't have to memorize the equation. If you get this idea, the logic, you can solve the problem. The air volume is angle is 360. It's 2p times area is here in centimeter square times distance to y-axis. Distance to y-axis is this one. This is, let's say this is the G point, which is xg. So if we multiply all these numbers, let's do it. 2 times p times this is the volume. Okay, at the end of the day, after you do all these calculations, the unit is important for us. Okay, the unit, because we have to know in which unit we are doing these calculations. Okay, you can write the result here, but you have to write the unit you get at the end. Okay, so this is the another example regarding the centroid and the volume calculation. Any questions so far? Is there anything you have trouble with? No, I think. I am going to do another example. Yes. Today I'm going to solve a few examples regarding the support reaction calculations and other stuff. I guess you understand the subject. I don't want to lose time regarding this subject. This is easy. If you do this table correct, you can do everything. Just you have to be a little bit careful. If there is a missing area, yes, put the minus in table. And the other stuff is just multiplication. You can do it all stuff with your calculator. It's easy. And then you're going to get these results. Okay, I'm going to solve support reaction calculation question.
Hocam bir şey sorabilir miyim?
Yes, please.
Aren't we supposed to take the distance to axis as 20 for the B part instead of 19.17?
19 point, where is it? 19.17. Here, you got, can you repeat it again?
Yes, I didn't understand why we took the distance as 19.17 instead of 20.
This one.
Yes.
Okay. Here, by the way, yes. This point, at the end of the day, after we did all these calculations, we have xg and yg. Xg and yg is the, let me change the sketch. Maybe the sketch may clear this part. Okay, after I did these calculations, I found the exact location of G for the total shape. Let's say it's here. Okay, I don't know where it is, but it's G. Now this distance is, according to our calculation, this one, right? Here, this part is this. Okay. Now this point is our center of gravity point. While we are doing a volume calculation, we use the distance from this point. So now we have the total shape, its center point is here. So what was the question? It was the volume around the y-axis. So the point is here, and distance to rotation axis is here. That's why we are using 19.70. Okay.
Thank you.
So we are not dealing with this rectangle. That's why in this volume calculation, we don't use the given geometrical dimensions. We use this coordinate that we calculated previously. Okay. Yes, we have. Actually, I have an example regarding the support reaction calculation, but it's a little bit long. Let's have a break now. Okay. 30 minutes, and when we come back, we can start that question. I don't want to split it to sessions, so in one session I'd like to explain how to do it. Let's have a break first. We are going to be here at 11:30. Okay, see you guys. Yes, let me share screen. Okay.
Hocam, I have a question. Are you going to explain the midterm, like how many questions gonna be like? Or
Actually, we are going to have 3 or 4 questions. It depends on the questions.
what about time?
1 hour. Well, actually, 1.5 hours.
Okay.
19 minutes. Okay, that's better. But we are going to start at 9 o'clock, I guess. Did you check the schedule?
Not yet.
Please check it. I guess our slot is 9 to 11. So we are going to start at 9, complete at 10:30. So 3 or 4 questions. It depends on the questions. Generally, at least 3, minimum 3, but sometimes we ask 4. So the questions will be really easy. We always ask what we did in the class. By the way, not the same question. Of course, you have to use what we learn in our sessions. So I think you can do that. This question, this exam is important. Why? Because the midterm exam, when you get final, you will be responsible all the subjects we learned. Here you have 3, I guess 3 subjects. So you have to get higher grades from midterm exam. This is a strategical approach. If you get higher in midterm, you will be ready for the final exam. So please study and just watch out what we asked. We will meet in person in the exam. It's gonna be the first time we meet. So please try to study. Don't wait till the last night. Okay.
Hocam
you
ben
do-
bir şey sorabilir miyim?
So
Bu şey mesela basamak sayıları alırken ilk 2 basamaklarını mı alıyoruz? Mesela 20/3'te niye 6,66 almadık da 67 aldık?
Yuvarladık sanırım.
şimdi 3'e mi bölmüştük? Kaça bölmüştük? Dur bakayım.
Üçe.
6.66, yani son 3.'yü de 2.'ye yuvarladım. Ama yani sen normalde bu yuvarlama şey, yani benim için 2 basamak önemli. Hani atıyorum 5 basamak da yazan çıkıyor da hiçbir işe yaramıyor, vakit kaybı. 5 basamak işe yaramaz. 2 basamak alınır bunda. Biz atom fiziğiyle uğraşmıyoruz. Sen 6.66 alsan da yanlış değil. Ama bunu hani bir yuvarlama mantığıdır diyelim. Onu işte bir sonrakini bir öncekine yuvarladık arkadaşlar. Tamam, oradan geliyor.
Peki bu küçük detaylarda çok bir puan kaybı yaşar mıyız? Mesela 2,66 aldık diyelim. Biraz daha küçük çıktı sonuç diyelim.
Arkadaşlar o sonuç ya biz o kadar da milimetrik o değil. Yani sizin zaten yaptığınız doğru mu yanlış mı olduğu zaten yaptığınız işlemlerden belli. Kendini
Tamam.
belli ediyor. Yani öyle 20 atıyorum 6,66 oldu diye puan kırmayız.
Tamam.
Yani öyle bir şey yok. Ama yanlış yani yanlış oluyorsa da o konuda biz hiç acımıyoruz arkadaşlar. Belki ikinci sefer alan arkadaşlar vardır. Hani acımıyoruz derken şöyle yani acımıyoruz. Kötü manada söylemiyorum. Yani doğru yaptığınız her şeyi biz değerlendiriyoruz. Elimizden geldiği kadar puan vermeye çalışıyoruz. Dediğim gibi geçen dönem biz maalesef ki uzaktan sınavlar yapmak durumunda kaldık. Yani biliyorsunuz işte şartlardan dolayı. Çok yüksek notlar aldı arkadaşlar. Hani ben aldıkları notların kendi notları olmadığını da zaten biliyorum. Kendileri de biliyorlar. Herkes biliyor ama yapacak bir şey yoktu. Çünkü ben 2015'ten beri bu dersi veriyorum. Yani Bilgi Üniversitesi'nde bizzat veriyorum bu dersi. Bu sınavın ortalamasının ne olacağını biliyorum. Mimarlarla çok uzun zamandan beri çalışıyorum. Mimarlık öğrencileriyle ki hani sizle çalışmaktan çok mutluyum, o ayrı bir konu. Biz burada arkadaşlar dediğim gibi normal İstanbul Teknik Üniversitesi'nde verilen eğitim sistemiyle eğitim veriyoruz. Bizi kimse ilgilendirmiyor gerçekten. O ayarda da soruyoruz. O ayarda anlatıyoruz. O konuları anlatıyoruz. Ve o ayarda da soru soruyoruz. O yüzden bence bu konuda herkes iyi. Çalıştığınız zaman çok daha iyi olacaksınız. Bu soruları hepiniz yapabilirsiniz. Yani biz arkadaşlar yüksek puan alsın diye sorularımızı veya konularımızı hafifletmiyoruz. Öyle bir şeyimiz yok. Siz çok iyisiniz ki ben buradan yıllardan beri mezun olan arkadaşlarla şu anda da hala iletişimdeyim çoğuyla. Ara sıra mesaj atarlar, işte sosyal medyadan yazarlar falan filan. Şu anda işe girdi mezun olan çoğu. Ee, Yani dediğim gibi arkadaşlar e, çalıştığınız zaman yapabilirsiniz. Sadece mantığını anlayın lütfen. Ezberlemeyin soruları. Çünkü soracağımız soru öncekinin aynısı olmayacak. Yani biz size çözdüğümüz örneğin aynısı olmayacak. Ama oradaki bilgiyi kullanacağınız başka bir şey olacak. Tamam. Mantığını anlarsanız zaten gerisi şu gördüğünüz hesap makinesi. Çarpma bölme. Çarpma bölme. Tamam. Şimdi vakit kaybetmeyelim. Okay, let's do our example. This is a little bit long example. This example covers many things in the question. So that's why I like this question. This was a midterm, no, makeup exam question a few years ago. Let me draw the system. This is our beam. Okay, here we have okay, and let me draw the loads in another color. Just a second here. Okay, here we have nodes here. So this load is here. And we have one more lateral load here. And one uniform distributed load here. This uniform distributed load is perpendicular to the beam here. And also here we have one more load. Okay, these are the loads. This is 4 ton. Here, this is 2 ton meter. We have a horizontal load at the top, 2 ton. Here we have a trapeze loading. It's here 4 ton meter for this point. 2 ton meter. Okay. What we need more? We need the spacings. Let's draw the spacings. Here we have and here 3 meter for 2 meters. And what's the height? The height is here 4 meter. Okay, good. Calculate the support reactions of the system shown under given loading condition. Okay, here we have our question. We have not a simple beam here. As you can see, we have a beam system like this. The black line shows the beam system, as you can see. This part. This one and this one. Okay. Let me show this part and further. Okay, this is our beam system. Now, what were we doing when we get a structural system and loading? Firstly, we have to put the unknowns to the to this structural system. Let's take a look at the first reaction, first support, actually. How many unknowns we have? When you look the support at the left, how many unknowns we have?
2.
2, yes. This is a pin support. So that's why we have 2, one vertical, one horizontal. If this is A, let me write here A, this is B. Vertical A, horizontal A. Okay, horizontal A. Let's have a look to point B. We have one more support here. What kind of support is this? What do you think?
Roller.
Roller support. How many unknowns we have?
1.
1, yes. Horizontal or vertical?
Vertical.
Yes, we have a vertical reaction here. We don't have any horizontal because it slides on the ground, on this surface. So therefore, there is no horizontal reaction. Okay, now we have all our reactions. That's okay. This was the first step. Let's jump in the second one. In the second step, what are we gonna do? Take a look at the loading. If we have distributed loads, what we do, we convert all these distributed loads to concentrated loads or point loads. Okay, so we have 2 different distributed loads. The first one is at the left-hand side, which is trapeze loading. The other one is uniform distributed load on the, actually, on the hypotenuse part of the triangle, as you can see on the beam. Okay, let's have a look the first one. Okay, how we convert trapeze loading to concentrated load? Do you have an idea? How we do this? Remember, if we calculate the area of this distributed load, we get the magnitude of the concentrated load. And also, we have to put this concentrated load to the exact location on the system. So if we have a trapeze loading, we split it to basic shapes, remember, like a centroid calculation. So for trapeze loading, if we divide it two pieces from here, we are going to have a triangle here and a rectangle at the bottom. So, okay, we divided two pieces, but what is this magnitude? What is this? What is this part? If this is 2, as you can see here, because it's 2, this part is 2. So calculate the area of this triangle. So 2 times 3 over 2. So the magnitude of this triangle is 3 tons. That's okay. It's gonna be around here. Let me change color, I guess. Okay, it's 3, but we need its location. Where is it? Where should I put this 3 on my structural system? So remember, it's like a centroid calculation. Again, 1/3 rule works for here. The bottom line, as you can see here, 3 meter. We are going to use 1/3 rule. This part here is 1 meter. The total is 3. That's why this part is 2 meters. So we put this 3 concentrated load 1 meter away from the pin support at the left-hand side. Okay, we have just found its location. Okay, we completed the triangle. Let's jump in the rectangle at the bottom. It's easy, actually. The area is as you can see here, a rectangle's area. The magnitude here is 2 times 3, which is 6, right? Which is 6. That's okay. The 6 is gonna be on the midpoint of this rectangle. The midpoint is, let's say, here. Totally is 3 meter. Here, this is 6. This is 6. So this is at the midpoint of this 3 meter. Here we will have 1.5 meter. And here at the left-hand side, again, we have 1.5 meter. Okay, is there any question so far? Is there any question regarding how we convert this trapeze loading to the concentrated load? Okay, I assume you fully understand what we did here, and it's really basic. Calculate the area that gives magnitude, find the center of gravity point, that shape, put the concentrated load to that location. Okay, this is the general rule for for the distributed loads. Okay, we have now two concentrated loads instead of this trapeze loading. One is 3, one is 6. And we are going to use their locations given on the sketch. Okay, we have just finished the trapeze loading. Let's do the uniform distributed load. By the way, I'm going to clear this part. Just a second. Okay, I'm going to write it here. 2-ton method. Okay, that's better. Okay, we have a uniform distributed load. By the way, why I solve this question? Okay, just a second. I will explain it in the next stage. Let's calculate the magnitude of this uniform distributed load. What we are gonna do? We are gonna do magnitude, this 2 times the length of this hypotenuse. Okay, let's calculate it. I don't have number. For just a second. For this length, this hypotenuse is 5 meter. 5.666 meter. Okay. You can calculate it. As you can see, this part is perpendicular. This is 4 meter. This is 4 meter. So we have a perpendicular triangle here. So as you can see, you can calculate the length of the hypotenuse. It's easy. So the length is 5.66 meter. So what is the magnitude of this uniform distributed load? 2 times 5.66. Actually, in my calculation, I get this part 5. Let me change here, 65. So the magnitude is ton. Okay, what is the location of this force? Any idea? That's the question here. Okay, we have a uniform distributed load. You get better understanding of how we calculate the magnitude of this uniform distributed load. That's easy. Calculate the area 2 times 5.65. That's okay. We have the 11.31 ton. Okay. Do you wanna draw the distributed or concentrated load location on the sketch? Or any idea? Do you have an idea? We have to understand this logic. That's why I'm asking this question. You don't have to memorize anything. Any idea in which direction is our concentrated load? What do you think? You're gonna say something, or we are gonna wait till you say something.
Maybe on the arrow's direction.
Actually, you're right and wrong. Actually, you're right. It's in arrow direction. Why you say maybe? Yes.
I don't know.
Yeah. Yes. If the loads in this direction, as you can see, they're perpendicular to the hypotenuse. Yes, this load must be in that direction. Sometimes, when I read this is exam question. When I read this papers, for example, some of our friends put the load like this, put the load like this. No, don't memorize anything. Please take a look the directions of given distributed load, and the resultant concentrated load will be in the same direction with the uniform distributed load. Arrows should be in the same direction. Okay, so we are perpendicular to this hypotenuse. Yes, its magnitude is this. So, is this clear for you? Did you understand this part? Why we put this arrow? Any question? No. Okay. So what we did here, we convert all the distributed loads to concentrated loads. But here, this 11.31 is an inclined force in the system. Okay, that's okay. We put the concentrated load to the exact location. But while we are doing hand calculation, it's not easy to consider this inclined, it's like this, inclined force in the questions. We generally do our calculations in the perpendicular axis, in the y-axis, in the x-axis. So let's convert this load to the components which are in the x and y axis. What I mean is, let me change color. Yes. Okay. We can represent this 11.31 with two loads. We can convert it to, we can resolve this load to these two perpendicular forces. Is it easy? Yes, we know the angle. Which angle? For example, this angle. What is this? This is
45.
45. Yes, you're right. 45. If this is 45, this will be, sorry, this will be 45. They're parallel to each other. And then again, this will be 45 because this is perpendicular to this hypotenuse. So the angle is here 45. Let's resolve this 11.31 to its components. Here, 11.31 times cosine or sine?
Cos for the horizontal one.
Yes, cosine 45. You're right. And let's change color for this one. 11 times sine 45. Okay. Now we have all loads in x and y axis. Actually, to clear everything, I'm gonna draw the system here again. When everything is one sketch, you may not understand what we are doing. I'm gonna put everything here now. Here, what we have now, we have three. We have three here. We have six ton here. Their dimensions are, this is 1.5 meter. Here for this one, this is 1 meter, 2 meter. Okay. And we have at the top, we have horizontal. Now at the midpoint here, what we have, 11. Okay, we have all dimensions here, almost 4 meter. Here we have 2 meter, but we need dimensions for the actually the spacings for this point. This is half of the hypotenuse, as you can see here. This was like, if you do, we need this distance. So it's gonna be, if you use the similar triangles, you're gonna see this part is 2 meter, 2 meter. You know, this is perpendicular again, 45 degree. Here is 2 meter. Okay, this comes from geometry. You can do it easily. Now we have all distances, spacings, everything, and all concentrated loads on the sketch. Now we can write our equilibrium equations. So this point is A, by the way, this is B. If we write the total MB equals 0. Let's write this together, guys. Total MB is 0. I'm gonna write in black. So here we have, by the way, let me write vertical A, horizontal A. Here we have vertical B. Okay. Now let's write the moment according to point B. VA, I assume that this direction is positive. Okay. VA times from here to here. What is the distance? 7 meters. 7. Okay. Now we are here, 3 ton. Is it positive or negative? As you can see, it rotates the system in the negative direction. If the upwards is positive, downwards is negative. That's why we put the negative here, minus here. So 3 times distance. The total was 7 meter. 1 meter is here. So the remaining distance is 6. Okay, let's do this 6 ton. Okay. Is it positive or negative? Any idea? This is negative. It's in the same direction like 3 here. So it goes downwards. That's why it's in the opposite direction of my assumption at the beginning, because I assumed the upwards is positive at the beginning. That's why this is negative. Put here a minus. Okay, then calculate the moment. Force 6 times distance. Distance is from this point to B, 4 plus 1.5, 5.5. 5.5. Okay. Any load here? I'm following the beam. Yes, at the top, we have a horizontal load, point load. So this rotates the system in this direction. So it rotates the system in this direction. Is it positive or negative? Any idea?
Negative.
This is the same direction with the first assumption or not?
Oh yes, sorry, it's positive.
Yes, it rotates the system because rotation is a complete action. So this rotates the system in the same direction as our assumption at the beginning. So the trick is here, actually, in this question. You need to understand if we are the positive direction or negative direction. This is important. Please watch out. Don't memorize anything while you are doing these type of questions. Okay. Only apply the rules. Don't overthink regarding the questions. Apply the rules. Look at here. This is in the positive direction. So this is plus force times distance to B. What is the distance to B? The perpendicular distance, by the way, because we are calculating moment. What was the moment? Force times perpendicular distance. Okay. What is the perpendicular distance here?
Or
Yes, of course. You're right. 4 meters. So basically the force goes like this. The distance, perpendicular distance here, 4 meters. Totally 4. Now, what we did? Yes, we are here. We are here. We are at this point. Let's take a look the vertical one first. Vertical one. Is it positive or negative?
negatif.
Yes, you're right. This vertical load rotates the system in this direction, downwards. So here we go, negative 11.1 sine. This is the force times the distance is 2 meters. 2. And what is this, by the way? There's something wrong here. I don't know why. Just a second. I'm just checking what I did here. This is correct. Okay. Now let's have a look the horizontal one. Is it positive or negative?
Negative.
Negative. 11. Now let me write here, by the way. Uh, 11/31 times cosine 45 times again here 2, right? Okay, now we are here at the end of the beam. There is vertical photon. Is it positive or negative?
Pozitif.
Yes, you're right. It's positive. The rotation point is this. Okay. When we apply this loading, it rotates the system in this direction. So it's in the same direction like the first assumption. It's positive. Positive. So here 4 times what? 2 equals 0. Equals 0. Let me check something here.
Hocam,
Sine.
can I ask something?
Yes, please.
I didn't understand why 3T and 6T are negative, but 4T force is positive.
You notice this one, why this is, and this is negative,
Yeah.
but this is positive, right?
Yes.
Okay. Take a look the rotation point. Where is our rotation point here?
B.
Yes, point B. When we apply this 3 or 6, it's in the
Mhm.
same direction. They are in the same direction. So 6, for example, rotates the system in this direction, right?
Mhm.
Because this is rotation point. The B is rotation point. But 4 rotates the system in this direction, depending on the rotation point.
Okay hocam, thank you.
Okay, they are in opposite directions. Okay, you get the point, I guess.
Yes.
Okay. There's something wrong here in my results. That's why I'm checking my results here. Let me check. Is it correct? Times sine 45 times 2, for example. Multi. Uh, 16. Let me check this part again. I'm sorry, I'm just checking the results. My solution is different here. I'm not following the papers I have while I'm solving. Did I miss something? No, we have 2 loads here. Yes, we have 2 loads at this point. We are doing correct. The one vertical, one horizontal. That's okay. No worries. This is, we are gonna check it at the end if we are doing wrong and right. Let's calculate the VA from here. VA from here. Here 18 plus 5 minus 8 plus times 2 plus times cosine 45 times 2 minus 8. Okay, over 7. Yes, here the vertical A is 9 tons. Okay, 9.57 tons. This is the vertical A. Okay, let's write the total MA equals 0 together. Now our rotation point is this one. Okay, we are gonna start from the right hand side, go to left. Okay, we are now, I'm gonna make an assumption for the positive direction. Okay, positive direction. Let's do it. This is the 4. 4 rotates the system in this direction. Okay, for moment A. So I made an assumption. This is positive. Okay, this is positive. So let's write it here. 4 times. What is the total length? This is 6 plus 3, 9 meter. Okay, we are here at the point B. Vertical B rotates the system positive or negative direction, depending on our assumption here. What do you think? This is negative because the downward, our assumption is this. Please take a look to orange ones. This is the positive direction. So vertical B rotates the system upwards. So that's why it's negative. Vertical B times distance is here to here, 7 meters. That's okay. That's okay. What we have here? What we have here? We have a horizontal, or let's do, no, yes, the horizontal one. It rotates the system in negative direction because this rotates the system in this direction. So minus 11.31 times cosine 45 times distance is 2. Okay, we did the horizontal one. Let's do the vertical one. The vertical one rotates the system in this direction. So it's in positive direction. 11.31 times sine 45 times distance is 2, 4, and one more here, 5 meter. 5 meter. 5. Okay, we did both of these loads at the midpoint here. Let's go to top of the triangle. We have a horizontal load here. It rotates the system in this direction, right? Is it positive or negative? It's positive. 2, that's why we have positive here. 2 times 4 here. The distance is 4, the perpendicular distance. Now, where are we? We are at 6 tons. 6 tons. It rotates the system in this direction. It's same like the initial assumption here. It's positive plus 6 times 1.5 meter. Okay. Now we are at 3 rotates the system in the positive direction. It's positive. 3 times 1 meter here. 1 meter equals 0. Now we have the equation. We have only one unknown, which is VB in this equation. It's easy to calculate if you have a calculator. So calculate the VB. And I'm going to write the result directly here. 11.43 ton. Okay. Any questions so far? Please try to get the logic here. I'm not doing a different thing here. It's regardless of the shape of the system. If I have the loadings on the system, I take the moments one by one and I check it's the sign. If it's positive or negative, then force time distance. That's it. Okay. Now we have vertical A and vertical B. Now we have just solved we did this one. Okay, this is checked. But we have one more here. Horizontal A. Okay, let's write the total X equals 0. So I assume that HA is in the positive direction. So HA is positive. Let's follow the beam. Is there any horizontal loading? Oops, here at the top, we have a horizontal 2 tons at the top point here. Is it in positive direction or negative direction? What do you think? Is this positive or negative?
Positive.
Yes, you're right. If we decide the initial direction, HA is in the direction, as you can see here, they are in the same direction. That's why 2 ton is in the positive direction, plus 2. Okay. Let's go ahead here. I'm going down. Oops, here. We have a horizontal loading, which is in the opposite direction of the HA or 2 tons. So that means it's negative. And its magnitude is 11.31 times cosine 45. Yes, we did this one, and we go ahead. The beam, is there any horizontal load? No, there is no more horizontal load on the beam after this point. Equals 0. Remember, for the what was our equilibrium equation? Total x is 0, total y is 0, total moment is any point is 0. Okay, so here, as you can see, what we did, we used total x is 0. And if we solve this equation, HA is gonna be 6 tons. Okay. These are checked. These are the support reactions. Okay. We have just calculated these support reactions. Let's do the check for our calculation. What we did. Are we right or wrong? What we can do, we can write directly total y is 0. This is the check. You don't have to do this, but I suggest you to do this one. Let me write it here, another color, in another color here. Oop. What is check? Let's write the total y equals 0. Let's do it. Here, what we have, vertical A. Let's say vertical A is in positive direction. What is the magnitude of vertical A? Is this. And here we have in negative direction 3. In negative direction 6. Okay. We are doing total y equals 0. That's why we are just considering the vertical loads. Okay, here. Any vertical load here, which goes downwards, 11 times 31. Vertical B goes up. What is the vertical B? Plus. This is the positive direction. And in negative direction, we have 4. Okay, let's do this calculation if it's 0 or not. Let me check it. I don't have this result. I will do it right now. This is almost zero, depending on the round up and round down. The result is like 2. This is almost 0. This is not a number, as you can see. This is almost small number. This comes from our rounding of numbers. But as you can see, this is 0. So our calculation is correct. Our calculation is correct. So we did the check. So we have just completed this question. Any idea, any question, any comment regarding this one? Okay, let's talk about the rules. When we get a structural system, okay, what we do first? Okay, let me hear from you. What we do first, regardless of the shape of the structural system or geometry of the structural system, what we do first?
Write the unknowns.
Yes, we first write the unknowns. We have to know how many unknowns we have. We have to put them, put the correct numbers. Okay. For example, if you have a roller support, you have 1 vertical. If you put there 1 vertical, 1 horizontal, you do the wrong things. Okay, be careful for this one. Yes, we did this first. And the second step, what we do? Okay, what we do in the second step?
Turn the distributed loads to the point loads.
Yes, we take a look to structural system. We consider all distributed loads one by one, and we convert them to the concentrated loads. Okay, we convert them to concentrated load. We can calculate the magnitude. It's easy because basically calculate the area of that distributed load. It's easy, but we have to put them in the correct location to the center of gravity point of that shape, that geometrical shape. Okay. So our concentrated loads direction must be like the same direction with the distributed load. As you can see here, the distributed load on the hypotenuse, you can see, when we convert it to the concentrated load, yes, we put a concentrated load in the same direction with the other arrows, distributed loads arrow. Okay, you know this. If you do this part correct, this is really basic. The other part is easy. You have to consider the positive or negative direction. You are gonna do an assumption at the beginning. You will assume one direction is positive. After that, you are gonna write all other moments according to that initial assumption. If it's negative, negative. If it's positive, it's positive. And do the calculation. We have 3 equilibrium equation: total x, total y, and total moment equals 0. If we write these equations for our structural system, you can do everything. You can do everything. Please don't memorize the questions. Okay. Just try to understand the logic behind our calculation. I don't want to memorize anything. I don't like to memorize. Okay, what you are going to memorize, for example, remember, if you are doing a centroid calculation, remember, if you have a 1/4 of a circle, you have to know what point is the centroid point of this shape. What was it? 4r/3p. Okay, you have to know this one. this is a geometrical issue. This is not about the statics course. You have to know this one. But other stuff is about logic. If you understand the logic, there is no question you can do. You can everything. When you okay, as you can see here, the shape of the beam or structural system is not a common system. It's like a triangle. There is a lateral line, there is a triangle, and there is a cantilever part at the right. Okay, whatever, who cares the shape? If you apply the rules to your structural system, to your question, you can solve everything. Okay, you can do everything. Please make some practice. You can find practice. By the way, you can watch the YouTube examples. There are many examples regarding this issue. But what I suggest you can take the question from YouTube easily and try to calculate yourself in our method. Sometimes in the YouTube channels, the other professors explain different methods. Okay, there are many methods to do this, but this is the basic one. This is the easiest one. Some methods are used by the engineers. Okay, you don't have to do that like this. This is the basic method. The logic is for each type question is same. If you do it, yes, you can solve everything. If you don't have any question, I'm gonna close the session today. Any question? Actually, Sizin, I don't know a special channel or tutorial. Firstly, what I suggest you, please solve the questions what we did in the class. Okay, please do it first by yourself, because here you have all the solutions, everything. After that, if you write support reaction to YouTube, you are gonna get many examples. If you write support reactions to Google, if you Google it, you are gonna see many examples. Take the example and solve these examples with our methods. Just check the results. Don't try to understand what they are doing there. Okay.
If you cannot understand, can we email you?
Sorry, say it again.
If we cannot understand or like get stuck at some point, can we email you?
Yes, you can do it. But if you do it on the last night, I can't help you. Okay.
No, we cannot.
Last night, I never answer. I don't reply back at last night because
we don't have actually a chance to like work at last night because all our week is full with everyday exam, like different exam every day. So.
Okay, wonderful. I like full exam weeks because it's good. It's good for you. That's why I guess you're gonna work for this stuff before than the last night. So okay, you can email me. You can...
Second time taking this class.
Okay. Okay. Thank you so much, ladies and gentlemen. Our exam is on 4th of December. As I said to you,
9 o'clock.
9 o'clock. Okay. We are gonna meet in person. I'm so excited to meet you in person. Actually, here it's not good. I don't like to explain this stuff online. But okay, we have to do this in this method. In next term, we are gonna do again on the weekends for the strength of materials course. By the way, I'd like to give a clue for you. Next week we will do it again on weekends because this week called me regarding this issue, and I accept to do this on weekends. Okay, if you have any questions, please email me before the last night, and I'm gonna try to explain your problems. Thank you so much. Have a good weekend. See you on exam. Okay.
See you.
Bye bye.
Thank you. Bye.
Stop the share.